So we now have our fly flying to a random point on the screen, and it stops when it gets there. And to me anyway, that's not very realistic fly behavior. Flies don't stop when they get to their destination. They'll pick a new one and dart off to that. So let's make our fly behave more like that. Once it reaches its destination, let's send it to a new one. So we first need to be able to detect when it's reached its destination. I'll put that logic in a new method called check reached destination. And every time the fly updates its location, we'll go ahead and check to see if it's reached its destination. And if it has reached its destination, we'll give it a new one. Remember this set new destination method. This gets a random position on the screen, and it will set the fly's destination to that position. So how do we actually check that we've reached the destination? The first thing that may occur to you is we can simply compare the location to the destination. So if they have the same x coordinates and they have the same y coordinates, then we've clearly reached the destination. So let's go ahead and test this. Our fly has reached the destination, but it doesn't seem like it's picked a new one. It hasn't, because if it had, we would output another line to the console here. So why is this not working? Well, let's put in some debugging statements. I'll output the location. Followed by the destination. All right, so we seem to have hit the destination. Let me pause this so we can look at the output. So the destination is 873.899. You can see that the fly is continually bouncing back and forth between 874 and 870, just overshooting and undershooting the actual destination. And the reason is we have a velocity of 5, so we're increasing the fly's position by 5 pixels with each iteration through the animation loop. So of course we're never going to hit a precise destination because we're not moving in continuous increments, we're moving in discrete steps by jumps of 5 pixels. So we're never going to exactly land on the destination. So doing this strict comparison is a fool's errand. We need to have a looser definition. We aren't going to exactly hit the destination. We just need to know when we get close enough to the destination that we consider it reached. So let's add a new utility method to our geometry class to find the distance between 2 points. It's going to look basically like the getAngle method. Call it getDistance. It's going to find the difference between from and to. So like the getAngle method, we want to find the delta x and the delta y between these 2 points. And then instead of taking the inverse tangent, we want to find the hypotenuse of the triangle defined by delta x and delta y. So that hypotenuse is that straight line between the points from and to. So this hypotenuse is the distance between those 2 points. All right, so like we did for the getAngle to point method, I also want one for getDistance to point. It's just a quick way to find the distance between the fly's current location and whatever the argument to this method is. And we said that we want to use that in our check reach destination method. Instead of actually doing a strict comparison, we'll get the distance to point, the distance to the destination. And we want to check if this is within some reasonable closeness. We want to check if this number is sufficiently small. We should define that threshold up with our other constants. and I'll call it close tolerance. I think 10 is a generous value for the close tolerance. When we were debugging this, we were seeing that we were getting within, well, we should always get within 5 pixels. We were seeing about 4 for the x coordinate and 1 for the y coordinate. So 10 should be plenty enough wiggle room that we will detect that we've reached the destination when we have. So if this distance is less than that tolerance, we can go ahead and assume we've reached the destination and pick a new one. So we no longer need these print statements. All right, let's see if this actually works. Awesome, yeah, we got a new destination after we hit that one. We just did it again. And let's see if we can do it a third time. Yeah, we did. So this is working. The fly is reaching its destination. It's picking a new one, and it's flying off towards that. So this is starting to look pretty good. In the next video, we'll review what we've done so far, and then we'll move on and see if we can make some even further improvements to this algorithm.